Today we will discuss few points related to the Otto cycle. So the Otto cycle, how to draw the PV and TS diagrams, the process involved in the Otto cycle. Today we will discuss. This is a very useful topic which helps your competitive examination. The Otto cycle, that is mainly used in the petrol engines. Already the components of the engine, the fuels used in the engine are well known. Suppose if it is the petrol engine that is works on the Otto cycle. What are the sequence of operations that occurred in the Otto cycle? And what is the thermodynamic operations rather? Those points we will discuss. Later we will try to practice drawing the PV and TS diagrams. So the air plus fuel that is used as the air plus fuel. So during the suction at atmospheric pressure and temperature, the mixture, there is a charge that is inducted into the cylinder. So at atmospheric pressure, the charge will be inducted into the cylinder and it is get compressed. So the first operation is the compression. The first operation is the compression. So at atmospheric pressure, the charge is admitted into the cylinder, it gets compressed. So the compression occurs. Thermodynamically, the compression is the isentropic compression. So the isentropic compression occurs in the engine cylinder. That is the first point. The second point, so the charge is injected, the charge is get compressed. Then the charge will be burned. The spark plug will be there. The spark plug ignites the charge. Then the charge will burn inside the engine cylinder. The heat addition occurs. So, if it is the Otto cycle with the sudden explosions, the heat addition occurs. So, then that is called the constant volume. So, during the heat addition process, the volume inside the engine cylinder is maintained constant. Therefore, the second operation is the heat addition. The heat addition is occurred at the constant volume. So the next the operation occurred inside the engine cylinder is the constant volume heat addition. So the charge is inducted, the charge is gets compressed, the charge is burnt. The huge heats are released, the gases are produced at the high temperature and high pressure. So inside the engine cylinder, the products of combustion are occurred at the high pressure and high temperature. They exert force onto the piston. So whenever they exert force onto the piston, piston moves from TDC to BDC. So that is get expansion. That is called the power stroke. So the third one is the expansion. The third one is the expansion. So during the expansion, the power is produced. So the compression is occurred isentropic. Similarly, the expansion is also occurred isentropic. So 3 to 4 is the isentropic expansion. So then after producing the work, the gases they escape out from the engine cylinder. Before they escape, the heat will be rejected fully. So the next operation is the heat rejection operation. So the heat addition is occurred at constant volume. Similarly, the heat rejection is also occurred at constant volume. So the constant volume, the heat rejection, that is the next process. So the compression, expansion, isentropic, heat addition, heat rejection, isentropic, constant volume. After this, the gases they leave the engine cylinder. So these are the sequence of operations occurred in the petrol engine. So how can we remember the process? The first one is isentropic compression. The second one is the constant volume heat addition. The third one is the isentropic expansion. The fourth one is the constant volume heat rejection. Therefore, the Otto cycle can be remembered as SVSV. This is the short form for remembering the Otto cycle. That is SVSV. That is from the Otto cycle. These are the sequence of operations occurred: compression, heat addition, expansion, heat rejection. The thermodynamic operations are like this. So SVSV, it is called the Otto cycle. So how can we draw the constant, the PV diagram and TS diagram for the Otto cycle. So 1 to 2 process is the compression. 1 to 2 process is the compression. Due to the compression, what happens? Pressure increases. Due to the compression, what happens? Volume decreases. So before compression, the volume is high and the pressure is less. That is the initial point. So the charge gets compressed. Because of the compression, volume decreases, pressure increases. Pressure increases. So 1 to 2 is the compression. The type of the compression is isentropic compression. So one important point you have to remember while drawing the PV diagram. So if it is a constant pressure process, horizontal. If it is a constant volume process, that is vertical. So constant pressure process is horizontal, constant volume process is vertical. Remaining all are the curved lines. So isentropic compression, that is a curved line. So initially state is 1, finally the state is 2. So 1 to 2 is the isentropic compression, which is occurred in the form of a curve. So 1 to 2 is isentropic compression. We reach a separate state 2. Then 2 to 3 is the heat addition. The heat addition is a constant volume heat addition. Constant volume is represented as vertical. Vertical upwards or vertical downwards. So whenever the heat is added, what happens to the pressure? The pressure will be increased. So 1 to 2 is the heat addition. 1 to 2, so the 2 to 3 is the heat addition. The heat is added into the cylinder at the constant volume. So the constant volume heat addition. Constant volume is a vertical. Then come to the next process, that is expansion. Because the expansion, isentropic expansion. So constant pressure is horizontal, constant volume is vertical. Other than this, all are the curved lines. So this is isentropic. Other than this, that is become the curved line. So curved line, either curved downwards or curved upwards. Expansion. Because of expansion, what happens? Expansion. Because of expansion, volume increases. Because of expansion, pressure decreases. So the pressure is get decreased. That is a curved downwards. So this is the isentropic expansion. After the gases get expanded, then the heat rejection occurs. So what is the type of the heat rejection? That is a constant volume heat rejection. Constant volume is again vertical. Constant pressure is horizontal. Constant volume is vertical. So this is a constant volume, vertical. Vertical upwards or vertical downwards. This is the heat rejection. Because due to the heat rejection, due to the heat addition, pressure increases. Due to the heat rejection, the pressure decreases. Therefore, the curve, the line 4 to 1 is become vertical. Vertical downwards. That is the constant volume heat rejection. So the compression expansion occurred isentropic, heat addition, heat rejection occurred constant volume. This is the method of drawing the Otto cycle, the PV diagram. Similarly, you can practice drawing the TS diagram. The TS diagram. So constant temperature is horizontal. Constant entropy is vertical. Other than this, curved lines. That is the one basic fundamental to draw the PV and TS diagrams. The first one is the compression. So you forget about the PV. Now you come to the TS. So 1 to 2 is the compression. Now what is the type of the compression? Isentropic compression. Isentropic. Isentropic. Entropy is taken on the x-axis. That is become vertical. So 1 to 2 is the compression. Isentropic compression. Because of the compression, pressure increases and also temperature increases. Therefore, it is drawn vertical upwards. Isentropic compression. Next, heat addition. To the constant volume heat addition. Constant temperature is horizontal. Constant entropy is vertical. Other than this curved line. This is other than this. Therefore, the heat addition is become the curved line. So 2 to 3 is the heat addition. Constant volume heat addition. that is curved upwards. Because of the heat addition, temperature increases, therefore curved upwards. So 2 to 3 is the constant volume heat addition. 3 to 4. Next process is expansion, isentropic expansion. Isentropic is nothing but the vertical. Isentropic is vertical upwards or vertical downwards. Because of the expansion, compression, pressure, temperature increases. Expansion, temperature decreases along with the pressure. Therefore, it is become vertical downwards. So this is the expansion. The type of the expansion is isentropic expansion. Immediately, if you mention the process names, you will not make any mistake while solving the problem. So you came up to point 4. So 4 to 1 is the heat rejection, constant volume heat rejection. Constant temperature is horizontal, constant entropy is vertical. Other than this, the curved line. Whether it is a curved upwards or curved downwards, the heat rejection. Due to the heat rejection, temperature decrease. Therefore, we have to draw the curved line downwards. So this is the heat rejection. The heat rejection is the constant volume heat rejection. This is a PV diagram. In the DS diagram for the Otto cycle. Suppose if you want to find the efficiency of cycle of any cycle, the work produced during the operations to the heat addition. Heat addition is the input energy. So that is taken in the denominator. What is the outcome? That is the work produced within the engine cylinder. So this ratio it is called the efficiency. The work. So the heat addition is this much, heat rejection is this much. Remaining, that is the work produced, that is used to produce the work. So W net model, that is heat addition minus heat rejection divided by the heat addition. So the thermodynamic relations, if you substitute the heat addition, heat rejection, if you simplify, you will get the relation. The relation for the Otto cycle is 1 minus 1 by R to the power of gamma minus 1 to the power of gamma minus 1. So this is about the Otto cycle. This is about the Otto cycle. So where R is the compression ratio. If you know the compression ratio, if you know the adiabatic index, then the efficiency can be estimated. Normally, the Otto cycles, they work with the efficiency 7 to 8%. 7 to 8%. So these are few points for the Otto cycle.